So in the previous model, we created 1,000 copies of our model to get our 1,000 different outcomes. Now that's not something we have to do, and it's not feasible for big models, and so we need a better tool for that. And what you guys already know data tables, I'm just going to show you a clever way to apply data tables to essentially make Monte Carlo data tables. So that's what we're going to do here. I've already set this up with trials from 1 to 1,000, and I've already linked in the total that I've gotten, which is the outcome for my game. All right, so the total is an 8, so I just want to see what are all the different outcomes that this game could be. So let's see what those different outcomes are, and let's build a data table. So just like any other data table, I have the value I'm interested in the top of the column. I've got my column inputs are just going to be my trials. So we select the whole column, data, what if analysis, data table, and now we need our column input cell. Now here's where it gets a little bit different from a traditional data table. Notice there's nothing that we have to change about the model. There's no input that we want to change here in every different trial. Instead, all we want to do is trigger the spreadsheet to recalculate. Right? Every time I hit F9, the spreadsheet recalculates. Also, every time I enter a number in any cell in the spreadsheet, it recalculates. So the random numbers are volatile and always recalculate. And so all I have to do is take these column inputs and put them somewhere in the model that it's not going to mess anything up. So for example, I'm going to pick this cell up here, I1. Right? Nothing in my model is happening there. I'm not going to overwrite something, like if I were to put it here in the CDF table. Right? That's not going to be good. Instead, we want to put it here where it's not going to mess anything up. So when I hit OK, notice everything looks the same because I have automatic except for data tables as my calculation option. Once I hit F9, now it all updates, and now I have 1,000 different outcomes. And you can see if I add up the number of 12s I have 33. I want to know a little bit more than that, though. I also want to know this win, lose, or draw outcome. So I actually want a little bit bigger data table. So let me delete this data table, and let's copy this cell and paste over 1. So now we're going to have what looks to be a two-way data table, because I've got values in the top and values down the column. But it's actually only going to be a one-way data table with just 2 different outcomes that we're keeping track of, both the 7, the actual total of what you roll, and whether you win, lose, or draw. So we're going to set this up. Again, it looks like a two-way data table, but it's really just a one-way data table now. And here we're going to do the column input cell, again, somewhere that we're just not going to mess up the model. So let's go ahead and put it back in I1. We say OK. Again, everything looks the same until we hit F9 to update. And now we get our dynamic model that we have 1,000 different outcomes from our trial. And now we can actually start to see that we can leverage this pretty quickly to see the variability in outcomes. Right, in this running, the expected value was, oops, we messed that up slightly. The count was off, so let's move this count right over here. All right, we have a 7 cents on average is what we're losing. If we refresh, now we lose 4 cents on average. Refresh 6 cents. 6 cents. So the average amount you lose is somewhere in that like 5 or 6 cents range. There's an 11 cents, so it can be quite a bit worse. 6 cents. So there's some variability in that. Again, the more trials you run, the more that'll even out, and you'll get a better precise estimate of that true average. But importantly, we're able to use the data table to generate those 1,000 different random outcomes. And what that means for us is we don't have 6,000 formulas in our spreadsheet that make our spreadsheet get bigger and more cumbersome and take longer to calculate. Because in that prior model, we had 1,000 copies of these 6 cells. So, 6,000 calculations versus 1 data table. It also only recalculates every time you tell it to with that F9 key. So there are a number of benefits to using a data table to build your Monte Carlo analysis, rather than actually just building a bunch of copies of your model. It'll make your spreadsheet faster to use data tables and just less calculations, and it's going to be more of a pleasure to use as well. All right, so there is one last warning I want to give you on using these data tables, and that is that you want to use only one data table with 2 of your outputs rather than trying to create 2 different data tables. And let me show you what would happen otherwise. So if we delete our data table, I'm going to move this cell over, and we're just going to make 2 data tables here. So our first data table, right, created it the same way, pointing at a cell that we're not using. And then our second data table, same idea, just a different output. Let's point at the different cell that we're not using. They could be the same cell. It actually doesn't matter here. And now we're going to hit F9 to update. And now what you're going to see is that there are going to be cases like this fifth row here where the outcome over here that you rolled a 10 does not match with what happens over here. So this says that I drew, which should be the case if I have a 7, but instead it's a 10. And the reason is that there are separate random numbers driving data table 1 and data table 2. The only way to coordinate those is to actually use the same data table like we did in that first example. So let's actually get back to that real quick. This is not the way you want to do things. We'll actually just delete these cells to clean everything up. And let's copy this over, rebuild our data table, again with 2 different inputs at the top. We're putting this in a random cell in our spreadsheet that doesn't have anything in it. Now our 2 columns of data are linked together. So when you see a 7, you see a draw. When you see a high number that's not a 12, you get a win. When you see a low number, you get a lose. So now we've used a data table to basically make a much more elegant Monte Carlo analysis. Now, the next step forward is to actually use VBA to build some of this in automatically into your code so you actually don't even have to rely on a data table. And that's what the next few videos are going to show you.